LP XXXX, or the LP relaxation. You might have more of decision variables. You might have an integer program instead of a bit, but you want to solve the LP relaxation of your original problem, because who knows? You might get lucky, right? Okay. What's the expression they say in the South? Even a blind hog finds an acorn now and then. So there you go. So that could be it. We could end up solving our integer program by solving the LP relaxation. Did that happen this time? There's the solution to the LP relaxation. Did we get lucky? Were we a blind hog finding an acorn? No. How come? How do we know that? It's not integer, right? 5, 6 is not an integer value. So we took our original problem, we relaxed the integer constraints, and we solved it using the simplex method or some other algorithm, and we ended up with an optimal solution that unfortunately was not integer valued. If it was integer valued, we could quit. How come we could quit if it was integer valued? There's no chance of doing better, right? If we add back in the integer constraints, it can only make the optimal solution worse, okay? Or it can make it stay the same or get worse. So, so unfortunately, we can't quit at this point. So one of the things that we could do then is this is what we do in branch and bound. Then we can define a subproblem in which we fix the value of x1. And of course, there are two choices because there are two choices for x1. So these binary branch and bound are pretty easy to think about. With integer programs, if you have more choices of what x1 might be, then you'd have more branches emanating out of this root node. So LP 0xxx is the LP that we get by doing what? It's the LP that we get by crossing out the integer constraints. And everywhere we see x1, what do? Put 0 in, right? Okay. So how many decision variables in that LP? 3, okay? Because x1's out of the picture, right? We set a value for it. Is everyone with me? Okay. Because this will be very easy if you're just paying attention. If you solve that problem, and you have to trust me on this, if you solve that problem, you will get an optimal solution of 0, 1, 0, 1. That's solving a linear program, not an integer program. What's good about that solution? It's the orange dot, okay? We just stumbled across it, okay? We stumbled across it. It's our orange dot now.